We are live, huh?
Thank you. Okay, Assalamu alaikum. Masā al-khair. Thank you, the team, for the invite for this new session. Another group, another region in Algeria. Thank you so much for inviting me. Hopefully, you will benefit from this session today. First of all, my name is Nabil. I am GDE Cloud. We'll be talking about Google Cloud Networking in this session. We're gonna see. We're gonna talk about the benefits of Google Cloud Networking, how Google Cloud do networking differently than other cloud providers, differently than anything that you've seen before. If you've worked with networking before, whether it's Cisco, whether it's your own company, university, anything that is hardware based, we're gonna see how Google Cloud is different than that. To start with, let me just have a brief introduction about generally what networks are about. So what is actually is a network? So a network consists of basically two or more computers that are basically linked in order to share resources. Resources like printers, like computers, like anything that exchange communication, electronic communication, information, exchanging files. And the computer on network may be linked through cables, maybe through fiber cables, radio wave, satellites, telephone lines, infrared light beams, anything that a medium to send that communication through. That's what a network is. And what types of networks do we have? We have what is called LANs and WANs, local area networks, when we're dealing with a network that is locally designed, locally produced, those locally configured. And we've got wide area networks. You could have a complete city that is networked across a wide area network. It could be a big university. It could be the whole country. It could be connected as a WAN. And these are kind of some descriptions. This is like a visualization. What would a local area network would look like? You can see here we've got this one here. What we call is a star design of local area networks. You will have a client server setup. You have the main server connected to different devices, PCs, Macs, printers. They're all sharing those resources across this network to the server, which is serving those data, those services to the whole of my network. So usually they use this for companies, even in at your home, if you have multiple laptops and computers and that are connected through Wi-Fi, for example, that's what a local area network. So communications happen privately. So we have what you call private IP address. We don't have publicly. We're not going publicly outside our local area network. A WAN is more complicated. A WAN is a set of LANs that we connect together. So let's say we've got a LAN. We have a big university or different departments that are in different cities, maybe. So we will have those LANs. They are connected together. We use bridges. We use routers. We use multiplexers to connect local area networks to those to compose that global communication network like a WAN. So the internet itself is like a WAN. So all the communication happen publicly through public IP addresses and things through the internet. So the internet is a big one, is big wide area network in that sense. And then what we have protocols. So in order to communicate between those server client or between a client and a client, we've got different types of data that we're going to communicate with. So it could be videos, it could be voice, it could be email, it could be files, and each one of those applications, they would need some sort of a different protocol. So a protocol is a set of rules. They govern the communication between those computers on that network, whether it's a LAN or the WAN, it doesn't matter. Anything that use kind of those data, you need some kind of protocol to talk. So in order to two computers to talk to each other, they must be speaking the same language, basically. So many different types of network protocols and standards are required to ensure no matter which operating system or network card or application they are using can communicate with another computer located either in the next room, the next desk, halfway around the world if we are using a WAN, through what is called the OSI model, so open system interconnection. So this reference model defines 7 layers of networking protocols. Each protocol is responsible for different type of communication. So the complexity of these layers is beyond the scope of this class. So I'm not going to talk about the details of the 7 layer. You can always look it up, the 7 layer OSA model. Very important to understand that if you are doing any networking course or something like that. Very important to understand that. So they can be simplified into 4 layers to help identify some of the protocols which you should be familiar with. So we've got TCP/IP, you've got HTTP, FTP, SMTP. So each one of those, they sit in different layer. So the application layer, this is the high layer there. This is where we talk about those protocols like HTTP, FTP, SMTP, DNS, and the other ones is responsible for different layers of communication. What do we use for to implement a network? We use first of all, on the computer themselves, we're going to use network cards. You're going to need some kind of cables. And those cables, they're going to be talking to switches, bridges, routers, firewall rules from security perspective to see which traffic can be allowed, which traffic cannot be allowed. And then in order to basically go into the file servers, this is where we're sharing that information to communicate it across our network. And then we have what is called the topology. So what is a topology? So this basically refers to how do we connect those computers, in which formats. We've seen that the first one, the star format, for example. So where do we put those cables? How do we set up our computers, in which layers and things like that. So main types of physical topologies that will help us in this session, we've got what is called linear bus, we've got star, and we've got tree, which is like an expanded star. So this is a linear bus. So you'll have one cable, and then you will be basically one kind of cable with the terminator of each end of that. And then from there, you can take your peripherals, your workstations, your servers, by connecting through those that cable there. Now, what is the benefits and advantages of that? Very easy to set up. So it's easy to connect to computer or to that line linear bus. You don't need so much cable. So one cable should be enough. You're just going to take some junctions from there and you connect your computers and servers and things. Disadvantages of that is that cable goes faulty, you lost all the network, so the communication all will be stopping. And the terminators are basically required on both those ends. So if it's open on one end, obviously the network is not going to work. If there is any problem somewhere in that network, it will be difficult to identify where the issue is, because it's only one cable, those junction is there. If you have got a communication issue on one computer, you don't know exactly where that issue is happened in that network. So this is kind of things that you won't be using in big companies. This probably using at home. If you have like 3 or 4 computers, you can use one cable and you can take junctions from that. That's as much as you can use it for. And then we've got what we call star. Star topology is designed with each node, file server, workstation, whatever, connected directly to a switch, a hub, or what we call a concentrator, sorry. So data on the star network passes through the hub or the switch or the concentrator before continuing to the other destination. So the control of the communication between those computers is all done at the switch level in here. So all the functions of the network happens at that stage here. So it also acts as a repeater as well. So the strength of the data of the communication, it's kind of reinforced in here, makes it stronger in there. So So this is what is common with a twisted pair cable, and it can also be used. Nobody uses it in these days. Coaxial cable or fiber optic. Also, you can use it in that topology as well. So advantages of that: it's very easy to install, very easy to wire. Um, if I remove something from here, it doesn't disturb the other ones. It doesn't stop others working. And this topology is very easy to detect any errors. So you can see red lights on the switch, or you can detect exactly where the port is an issue with. Disadvantages of that: you need more cable, obviously. These days is cheap, it's not an issue. Um, the other issue we have here, if this box here fails, you lost the network. So you need to kind of have some kind of high availability. You have to have another switch in parallel. If that fails, the other one will take over. And obviously, this is going to be more expensive than the previous one that we've seen. And then you have this expanded star. So this kind of combining both both topologies, the star and the linear bus. And obviously here it's you will have point-to-point wiring of individual segments, support by several hardware and software vendors. So it's more kind of a production enterprise environment. So you're having more cables in here. The thing is, if that backbone breaks, basically you have the whole segment breaks down here as well. So it's more difficult to configure and wire than the other topologies. So this is the other one that you can have that. You can have multiple cables as the backbone as well. So if one fails, the other one take over. So we can. This is basically the most famous ones that you can build on in a proper network. So this is just a general idea of when we use to design a network and what a network is about. Now we have what is called network operating system, NOS. So network operating system, basically when you have multiple networks and multiple computers across a network, we have an operating system just for the network as basically the director to keep the network running smoothly. So you can program your network from there. So it's basically the brain of your network to manage direct traffic from one segment to another segment and basically manage the network in general. And peer-to-peer, so you have peer-to-peer operating systems, basically allow users to share resources and files located on their computers. It's not very practical to do that, because if one computer goes down, you lose that data. It's very decentralized, very hard to, from security perspective, it doesn't provide you very strong security, not like the when you have a client-server setup. Client-server setup, this is the most popular one. So you have the centralized functions in a file server, and then you will have all the clients just getting data from those dedicated servers. So it's centralized, it's scalable, it's flexible. You can have multiple file servers as well, and accessibility to servers. You can get it from remote across multiple platforms. Obviously, this is more for big companies and enterprises. Obviously, it's going to have need more from in terms of maintenance. It's more expensive as well. And basically you got dependencies on those servers. So if one service goes down, you won't be able to get any resources available. So it's best to have multiple of those servers that are replicated, and then in that sense you will be more secure in that sense. So this is in general from hardware perspective. So there is a technology that came after that to make things easier, which is called SDN. So SDN, the cloud. So SDN, software-defined network. So the networks that we had a look at is everything that you're gonna do manually. So if you want to create a network, you need all those components that we talked about. You need a switch, you need cables, you need Ethernet cards. You need to basically you do all that manual work. You need to buy those devices, put the network together, manage it yourself, and things like that. So, and this basically didn't allow any big companies that are working across continents in Europe, the US, globally, make like things very difficult um, to scale, to have that resiliency, and to basically have things easier to be done. And this is what we call software-defined network. So basically, you will have all your hardware, your infrastructure at the back end, and you want to manage that from like a UI, from a GUI. So you set up all your at scale. You set up all your switches, your cables, and everything. And if you want to create a network in different areas, you just click boxes and you create it from a software. So yeah, I want a device in that area and that device in that area, and I want them to talk to each other. Or 5 servers that are in different areas. I wanted to forward network traffic from there, and so I don't need to create basically provide a switch and all those components. They're already there at the back end. I'm just going to have click boxes and on the software level to have that communication, to have my virtual network happening automatically for me, managing any virtual resources that I have. So this kind of separating, abstracting the operations of a network from the hardware itself. So all the operations of a network, I can do it from a software rather than, and this is what we talk about the network operating system. So I can go from network, I've got some GUI, and I create my network from that. And this is what allowed cloud providers to be using in order to have consumers using the cloud in that sense, consuming network applications, network resources over the cloud with this technology of software-defined network, the SDNs. And this is what basically bring us to talk about Google Cloud. So how is Google Cloud do their network? First of all, they need to have the infrastructure underneath. So they need to have all that cabling in place and all the hardware that we talked about that is available, but they need to have it at scale. So Google Cloud exists globally, like you see here, over um, the US, South America, North America, Europe, Africa, not that much. We're going to talk about those points, what they mean. We've got India and Asia, Middle East. We've got the Far East. We've got Asia there. We've got Australia, all those kinds of stuff. And the best way to look at that is, let me just show you the real map that goes here. So if I go to Google Cloud locations, I always want to show this because this is the most up-to-date. Make this bit bigger. Okay. So these are the cloud locations. This is the Google Cloud locations that we have in a look here. So this is what you see here. This is what we saw cabling. So this is all the fiber optic cabling that Google has invested in. So you will see all over the globe. This is their network, their own. So you've got submarine, you've got current network on the land. Anything that is green is subsea cable. So Google, they bought this shipping company, and they do subsea cables. So massive, massive, massive network. And on top of that, obviously, they invested in those switches, the routers. So they implemented the hardware bit. And on top of that, they put the software-defined technology on top of that. And this what allows them to, when we look at the regions here, you will see these dots. So these basically regions in different cities across the globe. So each region, it will be representing a city in one of the continents. And each of those regions, they will have zones. So a zone is a data center. So you will see anything that is blue, they will have 3 data centers in there. And the white is like the future regions. So they are investing more and more, Google, in more regions and stuff. And inshallah, in the future, we will see one here in Algeria. Why not? So we will see some cabling coming this way. So you can see there's no cables to North Africa. So hopefully in the future, we will see something happening here. And this is basically all the data centers. Now, the question that comes in, so if I have cables across all those regions, what happens for users in Africa? How do they get to the Google network and basically consume resources? And this is what we call edge points of presence. So the edge points of presence are network points where the cabling can reach out from the Google network to these points. Okay, so if I have users in, let's say in Algeria, and you want to use Google Cloud, how do you get to to those resources. I mean, the first thing that you need to do through your ISP, I don't know who that is in Algeria these days, and through that through the internet, you're gonna go to one of those locations first. You know, these ones that are in black, and once you are in there, basically you are on the Google network. So once you are in Google network, you can go provision any resources in any of those data centers across the globe. And this is what the edge points of presence are about. For us to be able to get to the Google network, once we are on Google network, we can leverage and use those resources. Okay. And then we've got what you call CDN point of presence. This is caching. So caching is very important. It will help us to be closer to our users. It will help us for latency purposes. So if I've got some data that is cached in one of the areas and I want to get that data, I will get to it quicker. So a very good example of that, how Google. A point that I missed to mention is that all this infrastructure that Google are doing is for their own applications to start with. So remember, Google, they've got 8 applications that are serving more 1 billion users each. So things like the Gmail, the YouTube, the Google search, all those applications. Actually, YouTube is 2 billion users these days. So imagine you have all those users. You need to have very, very capable network, very, very strong network, and the infrastructure of the networking, the switches, it needs to be very, very solid in order to serve that. So how many times have you heard like YouTube is down or Gmail is down? And it's because the Google have invested billions of dollars in that infrastructure for those applications to run smoothly. Now going back to CDN is that one point of because this cabling, this fiber optic, so throughput is very, very high. So if it's, let's say for example, somebody here, let's say in the US, is uploading a YouTube video, and somebody, let's say, is somewhere here in Australia, and they want to watch that video. So that video obviously is going to be stored somewhere here in the US. This guy here is going to watch that. So the first time he's going to basically, depending what he has in Australia, he's going to go to one of these edge point of presence to go to the Google network. And then he's going to bring that video across all the network through their ISP and then through the Google network, and then they're going to watch it. So you will see that video probably is at the beginning is a little bit slow. There's a bit of latency in there. And then what happens is that video is going to be cached in all those cache locations across the globe. And then if somebody else or the same person is going to watch that video, he's not going to bring it down from the US. Because that video now is cached, now he's going to be bringing it from that cache location, which means that there's no latency. You're not paying for all that data to come across. So it's near the user. So it's very quick, it's very efficient, and things like that. So these are kind of the capabilities that we put on the network. Okay, let me go back to the slides. Going back here. So this is what we talk about, the infrastructure of the network, and a networking cloud is a virtual network. So it's software defined. So when I create a network, anything that happens underneath, I don't see that. It's already, the infrastructure is already there, the cabling is already there, the switches are already there, the connections are already there. I'm just taking that layer on top and saying, okay, I want resources here, create me that virtual network for me, where I can have all my resources into that network. And this is what we call VPC, virtual private cloud. Virtual private cloud, this is the virtual network that we're gonna create on GCP. And that's basically will have your networks in it, you will have your sub networks, they will be in some kind of region and zone, a data center you're going to be creating it in, and it will include things like the IP addresses. You will be using virtual machines, routes, firewalls, all that. All those resources are going to be included in the VPC when you create it. Okay, when we talk about the project, this is basically the thing that you need to create first of all. So the project is basically a container that you need to create first, and then you put your resources. You create your VMs, you create your network inside that project. Any resources, any whether networking, whether it's VMs, whether it's storage, you create them inside that project. And that project, this is where you, where Google will send you the bill. Said that project this month has cost you 200 euros or whatever because you have used these resources. They give you a breakdown of that and things. And network will be at the first, when you create a network, nobody gives you IP addresses. IP addresses will be created after. It's a global and spans available region. We will see what that means. It will be containing subnetworks. We will see how subnetworks work in there. And you've got different types of what I got: default, auto, and custom. So the default network, because it's all software defined, every project will have a default network, and a default network will create for you. It will be basically a network that is available and that includes any region in the globe. So you will have one subnet, which is from networking perspective. You don't know what subnet is a section of a set of IP addresses, because each machine, like I said, in the network needs to have an IP address. So a subnet is a section of a group of IP addresses that are put together to be near to each other, to communicate with each other. So we will have a subnet in each of those regions. You will have default firewall rules with that, and that's by default. That's you get Google create that for you. Auto mode network, custom mode, you can also create that. So an auto mode network, you can create an auto mode network, and it will be doing the same. It will create a subnet for you for all the regions. It is /20 subnetwork. You can expand it to /16. And you have custom mode. Custom mode, you have to create those subnets. So let me show you I will show you a second in the console how it looks like. So let me just go to the console again and show you. If I go to what is my console? It's here. Let me see. Can you sound? So if I go to VPC, Virtual Private Cloud, VPC network, and let me log in with my So this is my console. Let me just go back to VPC, VPC network. Now I want to create a network that spans all the globe. So I can do create here. I can just give it a name. Demo, let's say workshop. And then if I do automatic, it will create for me a subnet in all the regions that we looked at in that, those locations like I showed you, where anywhere there is a region for Google Cloud, it will create for me a subnet in there where I can create my resources. So there is 25 of them. It will give me some firewall rules. I'm going to talk about them in a minute. And pretty much I'm done. So I'll show you an example of an auto mode network. This is an auto. So this demo here, you can see here I've got subnets in all the region: US Central 1, Europe, US West 1, Asia, Asia Southeast, which is India, I think, US is 4, Australia, Europe West 2, I think it's the Netherlands or UK or something, Asia South 1, all the regions. So the map I showed you, now I've got a network that spans all those areas there. Imagine if I wanted to do that with the hardware, that's few months work. That's at least about 6 month work. So I need to create a network in each of those regions, and then I have routers in each of those. I need to have some kind of communication between those countries through the internet. So I have to secure that communication through VPN. It will be like a nightmare of a project to do. Now in Google Cloud, that would take me maybe 1 minute to do because it's software defined. The infrastructure is already there. I've got my network all over the globe. Is it a good thing or a bad thing? Some of it is good, some of it are bad, because which companies got that presence across the globe? So if I create my network globally like that, it will be very hard to manage. So anybody can create resources. So I have ramifications when it comes to cost, when it comes to security, when it comes. So usually you have big companies, maybe they've got some presence in Europe, maybe in, let's say, Belgium, maybe in the Netherlands, and then maybe they have a small office or some offices in the US, and maybe they have one office or two in Australia if they are a big company. So what you want to do, you create a custom network in that case. So with a custom network, I'm no longer having Google Cloud to create me automatic network, so I can be more specific. So those subnets, I'll just create them wherever I want. So I create just the region that I'm interested in. So if I've got one region in the US and one in the, let's say, South America, maybe I've got one in Europe and maybe one in Asia. So if I'm a big company and I've got presence in those, so I create those, and then I'll be able to create resources in there. Let me show you an example of creating resources in different regions. So as I said, now in less than 1 minute, my network is ready to create those resources. Let's say I'm want to create some VMs. So let me just take an example, and I'm gonna be creating a couple of VMs in 2 different regions. So remember, a region is a city across the globe. A zone is a data center. So here I'm gonna create workshop 1 VM, workshop 01, and I'm gonna create it, let's say, in Netherlands. I've got 3 data centers. I'm gonna select one data center there, and I'm gonna specify other things like the operating system, the number of CPUs and memory, the operating system that I want, things like that. From networking perspective, I can select my network where I'm gonna put this. So I'll select the network that we had a look at. This one, for example. And let's see how long it takes me to create that VM. Workshop 2, I can create a second one, and I'm gonna put it in same network, but in totally different region. So workshop 02, and I'm gonna put this, let's say, in Belgium, for example. Okay, totally different country, but I'm gonna put it in the same network, the network that I've created. So they can communicate with each other, basically, just to prove to you I'm in totally different countries, but I can still make those 2 machines talk to each other. Done. So these are my 2 machines. Let me make this a little bit smaller. There you go. So workshop 01, I can SSH to this. So I'm going inside that machine. And let me make this bigger. And this is the beauty of cloud. Things like SSH keys, management of those SSH keys, encryption, and all that. This is all managed for me by Google. So I'm going from there. Let me just clear that. What I want to do, I want to just ping the other machine, workshop 2. And I'm getting a latency of 7.42 milliseconds. Something you might not, you probably don't get that even you are at your home on your Wi-Fi. You don't get 7 milliseconds. So you can see how powerful is the network on Google Cloud, because all that infrastructure, they own that. It's their network. They don't share it with anybody else. So this kind of latency that we get. So here in this demo, we just demonstrated that in less than maybe 3 minutes, we created a network that is spanning multiple regions across the globe. And I'm creating resources in there. I am in there. I'm using those VMs. If I want to do that from hardware perspective, this is few months work in order to create that network with those resources like that. So you can see the power of not just the network, but the cloud services that we're using here. So I think there is questions here. No, there's no questions. So if there's any questions, I'll see them on the comments in there, and I'll pick those up. So what's the benefits we're seeing here with this demo is a couple of things really. So here in this example, for example, I can create multiple networks on GCP. So I can create, if I have like two departments, we have two sub companies, I can create a network for each. And those networks you can see here, for example, this is one project, and I've got multiple networks. So I've got, for example, here 5 networks in here. I've created one VM. The network is VPC that I've created, so probably they are custom networks, and I created that. And I created the VM in a different network, and then in one of the VPCs I've created 2 VMs, but in 2 different regions, like the example I showed you. I created one in Netherlands and one in Belgium. So this is what it means. So two different regions. Now, when I use, imagine this is one region that I created is Netherlands, and this one is Belgium. So those two VMs, they are in the same network. When I did a ping, they will be able to talk to each other with the private IP. So I'm not using external IP. So the internal IP. So they're going through internal network. So which is cheaper, which is efficient, which is very, very fast. We've seen like it's around 7 milliseconds to talk to each other. Now, if I creating multiple networks in my project and created those VMs, those two, even though they are in the same region, I created them, whether it's in Netherlands but they are on 2 different networks, they can't talk to each other. I can't ping that with the internal IP. They need to talk to each other with the external IP. So they go to the internet in order to talk to each other and ping each other. So that's the difference between the use case or the example I'm giving here. In order for segregating networks, you might need to do that in some cases. So the point I wanted to make clear here that that the Google network is different than definitely when you are doing a hardware network or any cloud provider. They don't have these capabilities. They don't have the design of network like Google. So what we're saying here, the VPC, the Google network is global. So we're taking an example, 2 VMs in 2 different regions, they are on the same network. So I didn't have to create one network in this region and another one network in this region, and I had to bring a router between them and do some routing tables and routing rules and things to make that work. It's straight away, they are connected point to point, even though they are on 2 different regions. And that's what helps me to do. If I am coming from for example, my data center, If I doing my from my data center creating a VPN, I will just need one VPN connection. So if I'm connecting a VPN to one region, that means I am in that network. It doesn't matter where you are, which region you are in. So one VPN, I don't have to create a VPN gateway for each of those regions because it's one network. So one VPN is easy enough to have that connection across. I've got a couple of questions. Let me take those. So we see a group of companies providing cloud computing services. What are the differences between them? Cloud services. Okay, so okay, good question. So if a company is saying they providing uh, cloud services, it means like private cloud. Private cloud, that means only their users or from their company, they're using those cloud services. So you need to have a proper username and password. Nobody else can use that. So if you are working for, I don't know, company XYZ, and they're providing access to the services through the internet, so they have a GUI, like a UI, like the console that you've seen for Google Cloud, but it's their own services. So the difference is it's not public. Not a lot. Not everybody can use it. The resources are limited. They won't be able to provide resources like Google or Azure or AWS for anybody to create. So they probably have two data centers, and they make those resources through a GUI to be able to use those services for their private use, really, just for their own company. And the second question from Abdul Hakim: why do you think Google is distinguished in its cloud computing services? Okay, that's another good question. One of the things is the network. So I've just shown you here the power of the network. So no other cloud provider can do that. So from cloud services like this, if I go to Azure or I go to AWS, if I wanted to create resources in two different regions, I would have to create two networks separately and then do a lot of stuff in between them in order to get them to talk to each other. That's one thing. The other thing with Google, which is beyond the scope of this presentation, Google is about big data services. So they provide a lot of services to do big data analytics, machine learning. So they basically they excel at that. And one of the reasons they excel at that for data that is at petabyte scale and big data and stuff is because the first of all, the infrastructure is very, very powerful. So the network is so powerful, the hardware they use is so powerful. So they've got the resources in order to do technologies, innovation at that level. And the third question: do you think that the security service provided by Google can protect your project and your host from hacking? Of course. So Google, they say they say that security for Google is their DNA. So before they design anything, they start with a security layer and they build on that. So if you're thinking that you can secure your network or your services better than Google or better than any other cloud provider, you are mistaken for sure, because obviously Google, they have their own data centers. The data centers are secure, and they've got like layers and layers of security. So they've got what the six layer security. Let me just to give you an idea about security. We might have another in the future, a session about security in Google Cloud. So let me, okay. Maybe share something here that. So just to give you an idea of the scale of security, let me share this. It will be shared hopefully in the 6-layer security at Google. Okay. So I will ask the team to share that link in the chat, please. Thank you. So that's one thing. So that's one capability that we have with VPC. And see, there's a lot to talk about networking. So I'm just going to cover another couple of things, and I open for questions because we're about to hit the hour. So the other thing that is very, very powerful in here is the subnets. So you've seen that we created subnets everywhere in the globe. So we've got our network, and And the subnets in GCP on Google Cloud, it spans what is called, it spans multiple zones. So zones is a data center. So if I have one region, let's say in the Netherlands or Belgium or Switzerland, I've got 3 data centers. If I put VMs in those different data centers, obviously they can have different IP addresses, but they are on the same subnet. What does that mean, having VMs on the same subnet? Meaning, if one VM goes down, I can take that IP address, put it in that VM, and that VM will be taking the responsibility of that VM here. So it's good, very, very powerful in terms of um, high availability to fail over. So I can fail over to another data center. If one data center goes down, that VM, I can just change the IP address. I don't have to worry about the network. Just the IP is enough to change it. And we've got services in Google Cloud that does that automatically for you. So this is the second differentiator from networking perspective, that the subnets, they span multiple data centers. That's not capabilities that you can find in other cloud providers or in your on premises, for example. So if you have a data center, you've got 2 data centers, you will have specific subnet in one data center and specific subnet in the other one. If one VM goes down one data center, you want to fail over, there's a complex job to be done. So you need to create a new subnet, create that VM in that subnet with the same IP address. So it's a long process in order to do that. When you have a subnet spanning multiple zones, you can just fail over straight away. Just the IP address, change it. They are exactly on the same network. So if you have like a front-end application or front-end users, they don't even notice that you have failed over to another data center. So this is kind of another capabilities of the subnet. And the other one is I can expand subnets. So the subnets I can start usually from best practice. I can start small, and then I can expand on that. So if I need more IP addresses, so what do I mean by that? So if I show you this, and I think there was other things that I wanted to talk about, but I think this is going to be our last point, and we might need to have another session talking about network capabilities in Google Cloud. But let me just show you what the other thing I want to show you here. Let me go back to the Cloud Console, actually. So let me just go google.com. Okay. So yeah, Mohammed Al-Ghazali, I will answer your question. Just one second. So if I want to do a subnet cheat sheet, so the subnet mask sheet calculator. So here, what we're saying here, we're saying that if I create a subnet /30 or /29 or something, I can get 4 IP addresses. And then from there, if I want to expand, it will double each time. So 4, 8, 16, and so on and so forth, right? But you always have 2 IP addresses that are reserved for local for the network and for the default gateway. But in Google Cloud, you have 4 IP addresses that are reserved. So the smallest subnet I can have is /29. And then I can expand. You will never be able to shrink a subnet. So if I go to my VPC, for example, VPC network. Let me make this bigger. Too big, sorry. So you can see here my subnet /29, /28. So with /29, we said we can get 8 addresses. In GCP, they are reserved. So I only get 4 IP addresses. So if I go to so this is custom deb on Europe West 3. If I want to create, I was going to talk about this, but instance groups, basically creating a group of VMs all at the same time based on a template. So here, if I wanted to create 4 VMs at the same time, so Europe West 3, I think it was, Frankfurt, and I want to minimum of 4 VMs. I will talk about this another time, but let me create a template. So I'm going to create 4 VMs, and I'll give them like a template to be created to be all the same VMs. And this is what I was going to talk about load balancing and things, but obviously time is not allowing. So maybe another time. Yeah, so I'm happy with that. So I can create this. So this instance group is going to create me 4 VMs. So if I go my VMs here, I refresh. Is it on the other page? No. So it has created. Let me see my VMs. Zero instances, not configured. I'm sure I said 4. Maybe it didn't pick up that. Instance group, 4 instances. There you go. We just created them, I think. Okay, so these are my instances there. They are in Europe West 3C, and the subnet that is created on them. This is the subnet is this one. The subnet is /29. Okay, so we said we've got 8 IP addresses with /29. Google will reserve 4. Maybe we'll get another chance to talk about why do we reserve 4 for Google another time. But the point I want to make here, if I want to create another VM in the same subnet, let's see what's going to happen here. So if I go to create a VM in here, Europe West 3. Was it Europe West 3? Yeah, it was. And the networking is custom demo. That's fine. Belgium. Okay. Now, subnets, they can be expanded. So if you have a subnet in your company, on your network, you can expand it. But there is a lot of work to be done to expand the network, to expand the subnet, because you are changing the default gateway, you're changing the IP ranges that you are specifying. So if you are in your company, you're managing your network, you need to go to each VM and give it a new IP address and all that stuff. So you will need to reboot all the services they have an IP address in that subnet. So here you can see that I've got a failure. So here It's telling me that Belgium is exhausted, the IP space. I've got no more IPs in here. So what I can do, and this is the power of the software define. So I can go back to that subnet. Let me go back to this one here. I can just edit the subnet, double the IP space, /28. I'm not I'm not reconfiguring any of those VMs because the IP tables and the routing is all outside the VMs, so it's all virtual. It's going to be pushed to all the VMs to take that new configuration automatically. So it's not per VM. So all the VMs will access that data. It's all virtual, and it will be pushed to all the VM. Now I've finished. If I check my VMs, they're still all running. They still have their IP addresses. Nothing happened to them. If I go here, I retry that. Instance 7, let's see what's going to happen. You should have now an IP address that I should be creating. So a work like this, if you are on your company's network, this is a kind of a full day's work to be done. Now in under 1 minute, we are able to expand the subnet, create new resources without any issues. So this is like the power of the network capabilities in Google Cloud. So we've seen some of the capabilities today. I was going to show you other things like load balancing, like cloud DNS, like caching, like cloud armor from security perspective. So I wanted to show you a few things, but 1 hour is not enough. Maybe we have another session in the near future, and we go networking session 2, hopefully to build up from this one. So let me see now. I think it's question time. So I've got another question here. The biggest risk to cloud is the absence of an ocean. Traditional cybersecurity focuses on protecting the environment. Cloud environments are highly connected, which means that unsafe API and account breaches can present real problems. So, well, there is many tools in Google Cloud that protect APIs, that protect accounts, that protect. So you will have two-factor authentication. You will have service accounts. You will have encryption keys. You will have a lot of things that are provided by the cloud provider. Security at the end, when it comes to cloud, it's a shared responsibility. So if you have a bad username and password, that's not the fault of the cloud provider that you have 1, 2, 3, 4, 5 as a password, that it can be hacked very easy. If you make a cloud storage if you make a cloud storage bucket public and let everybody access in it, that's not the fault of the cloud provider. So the cloud provider will secure everything at the level of the service you're provided. They give you the tools to secure your data, and then it's up to you how you secure it. And they give you the best practices, they give you the documentation, and then it's for you to use those tools correctly. And this is where you comes like you need to have training, you need to read the documentation, you need to attend sessions like we are having today. Basically learning. Basically, well, like I said, knowledge is power. So that's the real thing. But there is a misconception that cloud is not secure. That's absolutely wrong. The wrong idea. Cloud is more secure than most of the companies that they have, because in order to be a public cloud provider, you will go through auditors. You need to satisfy a lot of requirements for the auditors from security perspective. So it is just kind of powerful security stuff in there. So it all goes back to that shared responsibility model that I'm talked about. So cybersecurity professionals need to shift to data-focused approaches. I agree with that. To the security risk associated with cloud computers has overcome. Yeah, okay. Google they have overcome that. There are a lot of services they provide that. To start with, from infrastructure as a service like VM, you've got firewall rules, you've got tools that are security center, they've got cloud armor, they've got for authentication, they've got cloud IAP, identity and access protection, identity access provider, so it will do authorization. They will have what you call VPC, service controls to control the APIs. They've got RPG Edge to secure APIs and things. So there's quite a bit in there to learn. The other one also, does it provide real and competitive solution compared to other cloud providers? Obviously, I'm not going to be biased here, but Google are one of the best cloud providers when it comes to big data and machine learning services built on their backend infrastructure. For the other services, they compete very, very well. So, I mean, each cloud provider, they got strong and weak points. The strong points for Google are their big data services, which are built on very, very powerful infrastructure. So big data, machine learning, they are big at that because that's their business. So that's what they run on. If you ask me what kind of techniques they run on their applications, from big data perspective and analytics and machine learning, all of them. So they got YouTube, Google search, the infrastructure they use, all the cloud services they provide, they basically started using them on their own applications. Machine learning runs on everything they run, and then things like that. So that's the other question. And we just hit exactly 1 hour, so maybe have another. So some questions, if there is, happy to take those. Okay, so here it means that artificial intelligence has big control over data security in Google Cloud Computing Service. Absolutely. So there is a lot from machine learning that is involved in security perspective. So think of it, I'll give you just a small example, DLP, which is data loss protection. So if your data has got things like you want to protect, for example, so you've got millions of records, and you don't want to show the date of birth or the security numbers from that data. You can protect it with a service called data loss protection, which is based on a lot of it based on machine learning and artificial intelligence. So Google Cloud DLP. I'm gonna share with you something there. Cloud data loss prevention. And if they protect against mass attacks and things, so they always have these kind of I'm sharing that DLP. So they've got machine learning to profile what kind of attacks they're having. So they always update the services like Cloud Armor, for example. Cloud Armor is a tool that protects against a set of IP addresses geographically or whatever. So anything they use in the backend, there is machine learning, even security as well. So I just give you an example with DLP. So I've shared that link. Have a look at the data loss prevention. It's a security tool for big data that basically in the backend use machine learning on it in order to have a look at those data that you want to protect. So that's also possible in there. Any other questions? Okay. Thank you so much for attending the session today. Thank you for inviting me. I wanted to share with you other stuff. Unfortunately, 1 hour is not enough. So hopefully, inshallah, we'll have another session to cover second part of networking, or maybe cover security. In the future, we might look at big data, machine learning, whatever you guys are interested in. we can cover. But definitely, if we're doing another session, I would like to have a second, maybe second part of networking, and we might do security after that, just to show you how secure is Google Cloud and what are the services that are available to help you in there. Once again, thank you for the invite. Jazakumullah khairan, and inshallah see you in the near future. Thanks again.